In this demonstration, you'll see two visual examples of how Cobalt from BluelightAI can be used to debug and improve a Retrieval Augmented Generation or RAG system. The first example will show how to disambiguate queries using visual cues, while the second will illustrate how to identify potential blind spots in an AI system's knowledge base. These examples will demonstrate how Cobalt's visual approach can enhance prompt engineering and improve AI model performance. This demo will show two examples where we use Cobalt to investigate a Retrieval Augmented Generation or RAG system. What you're looking at right now is what we call a data landscape. It represents a collection of news articles collected between the years 2016 and 2020. The nodes in this network represent news articles, or groups of news articles to be more precise. Let's select this group at the top and see what it's about. If we look at the summary table, we can see that it's mostly finance. Cobalt also allows you to take the selection and ask ChatGPT to summarize it instead. Next, let's type in a query and look for documents that match it when I ask about the draft. You'll notice that the data landscape just changed colors. Yellow nodes in the network represent groups of documents that match my query with a high response score, and dark blue nodes represent documents that probably aren't relevant. Cobalt automatically creates these colorings in response to a user's query. There are two distinct areas on the left and right sides that indicate a positive response. Let's see what makes these groups different. We'll look at the group on the right first. When I select the group on the right, you can see from the summary table that it's mostly about sports. It's no surprise that ChatGPT is probably going to agree with that. If we look at the group on the left instead, we'll see what ChatGPT thinks of that group. It's more about the military. So, based on that, we should refine our search to disambiguate, specifying the NBA draft in our query. This time, I asked it specifically about the NBA draft, and we've restricted ourselves only to the group on the right. This use of visual cues is central to Blue Light's approach for improving generative AI models. However, automation is also an option for those who prefer to skip manual visual inspection. For example, mode-seeking algorithms like mean shift from sklearn can be employed to automatically discover these groups within the data, streamlining the process while still identifying key patterns. As we just saw, Cobalt enables us to visually explore a document collection and get an intuitive sense of how the AI system responses relate to different subsets of the data. By selectively focusing on the most relevant document groups highlighted by Cobalt, we can refine our queries and prompts to steer the AI towards more accurate and contextually appropriate outputs. While that use case illustrated how to disambiguate and narrow down based on text relevance, the true power of Cobalt lies in its ability to reveal insights that may be missed without visualizing the high-dimensional data landscape. The next example will showcase how Cobalt can identify blind spots or gaps in an AI's knowledge base by surfacing areas of the data space that are underrepresented or lacking sufficient coverage to illustrate how the quality and relevance of the underlying data affect an AI model's responses. I'm going to set up a deliberate mismatch between our query and the available information. This strawman scenario will demonstrate what happens when the data set, such as LLM training data, doesn't align well with the question being asked. I'm going to ask a question about social distancing, but I'm going to restrict myself only to information from before the year 2019. The coloring indicates how strong the response is, with bright yellow indicating a positive response and dark blue indicating a lack of response. We can see that it's scattered all over the place and it's not concentrated in any particular group of documents. If it were, we would see a bright yellow group clustered close together. This scattered pattern indicates the increased risk of hallucination in generative AI models. When information is dispersed and inconsistent across many documents, the model may struggle to find a coherent narrative or consistent facts. That's because social distancing wasn't in the news prior to 2019 in any meaningful way. In such cases, the model might attempt to piece together an answer from loosely related concepts, potentially leading to inaccurate or fabricated information. If I change my prompt to only look at 2019 or after, we can expect a much different response. It's not surprising that there's a very concentrated group here, and we can verify that it's exactly what we expect it to be. This concentrated group of documents likely reduces the risk of hallucination. When information is densely clustered and consistent across multiple sources, the model has a stronger foundation of factual relevant data to draw from. This doesn't eliminate the possibility of hallucination entirely, but it does provide a more reliable basis for the model's responses. Let's recap the key insights from our demonstrations. In our first example with the draft query, we saw how Cobalt's visual interface allowed us to quickly distinguish between sports and military contexts. This visual disambiguation led to more precise context-aware outputs, enabling us to refine our prompts more effectively. Our second demo, focusing on social distancing, illustrated how Cobalt visually represents data relevance across different time periods. This capability helps identify potential blind spots in the AI's knowledge base, ultimately leading to improved model performance by ensuring we're using the most relevant data. These demonstrations highlight how Cobalt's unique approach to visualizing AI knowledge can significantly streamline the prompt engineering process, potentially reducing the number of development cycles needed to achieve optimal results.